We are starting with question 150 where we left off on Monday. So remember, this question says, a football player attempts to kick a football over a goalpost. The path of the football can be modeled by the function h of x, and we're given the equation, where x is the horizontal distance from the kick, and h of x is the height of the football above the ground, when both are measured in feet. On the set of axes below, graph the function y equals h of x over the interval from 0 to 150. So far what we had done is we put the function rule into the calculator, and it looked like this. Then we figured out what that maximum was, because we wanted to know, hey, how high did the ball go, so we can figure out what scale to put along the y-axis. So we figured out that the highest that the ball goes is the 25. We were given the domain from 0 to 150, so along the bottom we made a scale of counting by tens and skipping every other line. Along the side, to get up as high as we needed to go, we figured out that we could count by twos, and I labeled mine just every 10. So then we went and we got the points from the table in the calculator, Control T, and when we look at these points, we can see many of them are decimals. We do have 0, 0, a bunch of decimals, 15, 9. So what I did is I already went through the table and I copied down all of the points that were the good points that we would want to graph. So you can go back later if you need to into the PDF and write down and graph those points. So the next thing I'm going to do is I'm going to label my axes, and then I'm going to worry about what else does the question want me to do. So it says where x is the horizontal distance from the kick. So down here along the x-axis, I'm going to write horizontal distance from kick, and that is measured in feet. H of x, both are measured in feet, so that's right, so this is feet. My h of x, or my y-axis, is the height of the football above the ground. So let me see if I can squeeze in height of ball, and again this is in feet. So now I'm going to worry about answering the rest of the question. This was a 6-pointer. Just doing the graph is worth 2 points. The next 2 points comes from determine the vertex of y equals h of x. Interpret the meaning of this vertex in the context of the problem. You would have seen just that part with a blank space beneath it before it kept going to the third part of the question. So if it wants to know determine the vertex is like the turnaround point. Where did the ball stop going up and it started coming down? We took a look at that on Monday. We put the point, the maximum point in there, and it worked out to be 75, 25. Just writing that down, that's another point for this solution. So I'm going to write down 75, what was it, 75, 25. Yep. Even if you hadn't graphed it on the paper and you had just graphed it in the calculator and figured out the vertex, you could have gotten a point. Interpret the meaning of the vertex in the context of this problem. This doesn't mean that the graph goes up 25. It doesn't want to know that. It wants to know in this football problem, what does 75, 25 mean? Okay, the 75 is the x. X is horizontal distance from the kick. So once the ball has gone 75 feet, 25 is the height of the football. How high is the ball? The ball is 25 feet. So we'll say that the vertex means the ball is 25 feet up in the air, 75 feet from the kick. That's the interpretation of the vertex. The third part of the question adds a little more. The goalpost is 10 feet high and 45 yards away from the kick. Will the ball be high enough to pass over the goalpost? Justify your answer. Okay, so we're being told that a goalpost is 10 feet high. I didn't know that. And the goalpost is 45 yards away from where the ball is being kicked. Will the ball actually be high enough to go over the goalpost? All right, well, it's saying that the ball is 45 yards, but the goal is 45 yards away from where it's being kicked. We measured along the x-axis in feet. So I need to know, all right, 45 yards, how many feet is that? 45 yards. Do you remember that there's 3 feet in a yard? So we'll multiply it by 3 feet. How many feet is that? It's 135. Oops. 135. So at 135, I did the same thing. At 135 feet from the kick, how high is the ball? All right, well, I'm going to go over here onto my graph. I'm going to measure out to 135, which is right here. That's 135. The ball is the goalpost is 10 feet high. Can I draw a little goalpost in here? So I follow the 10 over. Here's the goalpost right there. Right there at 10. Did the ball go over or under it? Well, the blue line goes underneath that line of 10 feet. So did the ball make it over? No. So we need to answer the question. Will the ball be high enough to pass over the goalpost? The ball will not pass over the goalpost. Justify your answer. You have to say a little more. You have to say why. Well, how high is the ball at 135 yards? According to the table, I'll scroll down, at 135 feet, the ball is 9 feet high. If the goal is 10 feet high, it can't go over it. The ball will not pass over the goalpost because it is only 9 feet high. We've got a visual there of a goalpost, but we have to say why it's actually not going over. It's only at 9 feet high. So that gets you the full 6 points. So now we're going to move into some different kinds of problems that apply operations with our polynomials and our binomials in some different kind of ways. So now we're going to go to 151. In 151 it says, Sam and Jeremy have ages that are consecutive odd integers. The product of their ages is 783. Which equation could be used to find Jeremy's age? J, if he is the younger man. So we need to do some figuring out what these words mean. The first word I see is consecutive. Consecutive means numbers that are in order. Odd is the next word I see. Odd numbers mean like 1, 3, 5, 7, 9. Numbers like that you can't divide by 2. The product of their ages. So now I've got another word in there. Product is which operation? Multiply. If I multiply their ages, I get 783. Which equation could be used to find Jeremy's age? J, if he's the younger man. So we know that Jeremy equals J. Jeremy's being represented by the variable J. That's what all the J's mean in our answers. All right, well, we also have Sam. If Jeremy and Sam's ages are represented by consecutive odd integers, it means their ages could be like 25 and 27. Those are both odd integers, and they're consecutive because they come right after the other. 25, 26, 27, 25 and 27 are the two that are close together. So using these as an example, how do we get from a 25, pretend that's J, to a 27? Well, 27 is 2 more than 25. So if I add 2 to Jeremy's age, I would figure out the next consecutive odd integer. So I'd say J plus 2 is Sam's age. Now I'm going to go and I'm going to figure out what my answer is. All right, product. Product means multiply. If I take J and I multiply times J plus 2, wait, I have to multiply times everything that's J plus 2. I'm supposed to get 783. Okay, well, I take J and I multiply times J plus 2. Parentheses. Parentheses mean distribute. J times J is J squared. J times plus 2 is plus 2J. So which one has a J squared and a plus 2J? Choice number 3. So a different way of looking at these polynomials, binomials, and operations with them. 152. 152 says, the length of the shortest side of a right triangle is 8 inches. The lengths of the other two sides are represented by consecutive odd integers. Which equation could be used to find the lengths of the other sides of the triangle? All right, I see the words right triangle. I gotta get a visual of what a right triangle looks like. A right triangle has a right angle in it, a 90-degree angle. Do you remember a formula about the sides of a right triangle? Something called the Pythagorean theorem. A squared plus B squared equals C squared. That tells us the relationship between the sides of a right triangle. C is always our hypotenuse, that longest side, and A and B are the other two sides, the legs. So now I'm going to use the information from the problem, and I'm going to figure out what are those sides being represented as. So let's see, the length of the shortest side is 8 inches. Well, the hypotenuse is always the longest side. So one of the legs, either A or B, we'll say is 8. The lengths of the other two sides are represented by consecutive odd integers. There's that consecutive odd thing again. Okay, well, the hypotenuse has to be the bigger one. So the hypotenuse is like that older person. So I'll call B side X. The next consecutive odd would be to take X and add 2 to it. So I'll say the hypotenuse is X plus 2. Now I'm going to chug that information, those sides, into our Pythagorean theorem. So my side A, I called 8 squared, plus my side B, I called X squared from the formula. My side C is X plus 2 in parentheses squared. Do I have an answer that looks like that? Well, pretty much. I see the X plus 2 squared in 2 of the answers, 2 and 4. And then, let's see, oh, no, not 2. 2 has a 1 in it. That's not the answer. It has to be choice 4. All I've done is I've used that switching the order property, commutative property, to say, hey, A and B, those could have been written backwards. Choice 4 is our answer. 153. Joe has a rectangular patio that measures 10 feet by 12 feet. He wants to increase the area by 50% and plans to increase each dimension by equal lengths, x. Which equation could be used to determine x? Anytime I'm given a shape, I like to draw that shape. I like to get a visual of a rectangle. We're given the original dimensions of the rectangle, 10 and 12. He wants to increase the size by 50% and plans to increase each dimension by equal lengths. So he's going to add on to both of these sides by the same amount, maybe 2 feet, 5 feet, 10 feet, who knows. We're just told that amount he's adding on is x. So our two sides are going to be 12 plus x and 10 plus x. So automatically I'm like jumping on the answers because I see 10 plus x and 12 plus x in choice 1 and 2. But the difference is 120 and 180. Where do those numbers come from? Well, I'm going to go back to the original shape. The original shape was 10 by 12. What's the area of a rectangle that's 10 by 12? We multiply length times width, 10 times 12 is 120. That's the original area of the deck. So choice 1 cannot be the answer because that area is the original area, not the new area. It has to be choice 2, just by process of elimination. And it works out to be that because if we have an original area of 120 and we add 50% more, 50% of 120, we multiply times 0.50 is 60. Well, let's add that 60 new square feet into the area. We get 180 as our total new square footage, or total new area. 154. A landscaper is creating a rectangular flower bed such that the width is half of the length. I see a rectangle in the problem. I'm going to draw a rectangle. The area of the flower bed is 34 square feet. Write and solve an equation to determine the width of the flower bed to the nearest foot. We're given that the area is 34. Where does area come from? Length times width. Okay, so we've got to figure out how to represent the length times the width. We're given that the width is half the length. The width is half the length. Whatever the length is, the width is half of that. All right, so, well, I'll call my length x. The width is half of that. Take it, cut it in half. The width is half the length. If the length is x, the width is 1/2 x. And you know what? In the scheme of things, if you wrote those backwards, it wouldn't really matter. Because area is length times width. Area is length times width. And if we switch the order in multiplication, community property, we get the same answer. So my formula turns into x times 1/2 x equals 34. All right, well now I got to do some math here. X times x is x squared. So 1/2 x squared equals 34. I want to get that x by itself. So let me get rid of the 1/2. I can divide it out or multiply by the reciprocal, 2/1. When I do 34 divided by 1/2, I get x squared equals 68. Now there's two things we could do. We could take the square root of both sides, or we could move the 68 over to the other side, graph it, and find the zeros. Let's just take the square root. I think it'll be the shortest way to do this. When we take the square root of both sides, we get x equals 8.2 rounded to the nearest tenth. Okay, well the width was half of that. The width is half of the length. We figured out that this side right here is 8.2. What's the other side, the width? So I'll say, hey, what's half of 8.2? I get a width of 4.1. Remember, there is also the positive and negative answers for 8.2, but does it really make sense to have a length of a side of a rectangle as negative 8.2? No, I wouldn't even bother worrying about that. It's a positive number, so just write the positive answer there. 155. A rectangular garden, and I already have a picture of a rectangle, measuring 12 meters by 16 meters, is to have a walkway installed around it with a width of X meters, as shown in the diagram below. So we've got our original garden. I'll put it like in green right there. That's the original garden. And then they've put a walkway around it. And the width of the walkway is X all the way around it. Together, the walkway and the garden have an area of 396 square meters. Write an equation that can be used to find X, the width of the walkway. Describe how your equation models the situation, and determine and state the width of the walkway in meters. All right, let's answer all those questions. So first, we need to write an equation that can be used to find X, the width of the walkway. Okay, well, we were told one of the areas. Were we told the area of the garden or the entire picture? Well, it says together the walkway and the garden have an area of 396. So that 396 is the entire outside rectangle. Area of a rectangle is length times width. Okay, if area of a rectangle is length times width, I need to know what's the total length of the garden and the walkway. So when I look at the length of the garden, it's got some additional pieces for the walkway, and both of these are X. So my total all the way around the outside is X plus 16 plus X. X plus 16 plus X. I've got two X's, combine them together, 2X. So my total length is 16 plus 2X, or 2X plus 16. I'm going to do the same thing for the width. If I've got a width over here of 12, I would be adding a walkway on one side of it and a walkway on the other side of it. There's two X's and a 12. 12 plus 2X. So this side over here, 12 plus 2X. Now I've got my length and my width, and I can write an equation for the area of the entire shape. So my area is 396 equals my length, 16 plus 2X, times, so I put parentheses around it, my width of 12 plus 2X. If you write small, you're going to be able to fit all of this in here. Okay, so now it says describe how your equation models the situation. You know what? With my diagrams in here, with these pluses and stuff, it kind of does describe it, but you could go into more detail and say that the length is 16 and 2 walkways. The width is 12 and 2 walkways. Even better if you draw arrows from like the length is the 16 and the width. It shows me where in the formula it came from, or in the equation it came from. Determine and state the width of the walkway in meters. Notice how it did not say algebraically. If it doesn't say algebraically, yes, you can use your calculator to graph and find the zeros. The only work that we would need to do is we would need to get rid of the 396, move it to the other side so that it says 0, and then we can go ahead and graph it in the calculator. So let's rewrite it without the 396 on the left side. Remember, it would jump over to the other side and it would turn into a negative. So our equation that we're going to graph is 16 plus 2x, 12 plus 2x, minus 396 equals 0. I'll go over to the calculator and I'll do that. Okay, so I'll get rid of my old graph. Bring up my box to type in. There it goes. All right, so I need a 12 plus, where's the brackets? Go away. Parenthesis, there we go. 12 plus 2x, parenthesis, parenthesis, 16 plus 2x, parenthesis again, minus 396, and hit enter. Whoa, that almost looks like a straight up and down line, doesn't it? I bet if we zoom this out or adjust our scale, you know what, I think I need to go the other way with it. Let me try negative 20. There we go. It does come back down again. We could adjust the top number, maybe a 50. Whoa, I think it actually opened up the other way. Let's try like negative 30 down at the bottom. Whoa, it really goes down low. But we can start to see the parabola shape to it. We can get our zeros, menu, analyze graph, 0. We've got 1 over there. Menu, analyze graph, 0. We've got 1 over here, and I can move my label out of the way. So we see that the two zeros, the two answers to the equation would be negative 17 and 3. So I'm going to pop back over into my equation. I'll say x equals negative 17, x equals 3. If you're worried about did I have to explain anything, you can say zeros from calc. But then you have to ask yourself, does that answer make sense? Well, if x means the width of the walkway, how do you have negative 17 feet as the width of the walkway? You can't. So we would say, that's not the answer. How wide is the walkway? 3. 3 what? Determine and state the width of the walkway in meters. Oh, okay, it's 3 meters. I thought it was feet, it's meters. So that's a pretty wide walkway, 3 meters, all the way around. Does that make sense? Yeah, it does. Negative 17 didn't make sense. 156. Remember on Monday I told you to put 156 down below 149. So when you flipped over to page 35, right next to it, below 149 is where you should put the work for this one. So 156, a contractor has 48 meters of fencing that he is going to use as the perimeter of a rectangular garden. The length of one side of the garden is represented by X, and the area of the garden is 108 square meters. Determine algebraically the dimensions of the garden in meters. All right, rectangular garden, I draw a rectangle. You can put this right underneath where the problem is written. Just draw a rectangle. The perimeter is 48. What does perimeter mean? Well, perimeter is the outside, all of the sides all together. Okay, so he has 48. Ooh, I just gave you part of what you needed. That's what we weren't given. What we were given is the area. My goof, I was looking at my diagram. The area of the garden is 108. So I was going to start with that first. The area of the garden is 108. So the length times the width is the area. The length times the width is 108. When I read that the contractor has 48 meters of fencing that he's going to put on the perimeter, oh, it was there. Okay, that's where I put P equals 48 from. The perimeter came from, well, how much fencing does he have to put around the outside? P equals 48. We were given one more piece of information I could put into this diagram. The length of one side of the garden is x. So I could pick one side and I could put x there. Well, wait, if that side is x, another side is also x. The one across from it. So I can label that one too. Now I'm going to worry about the whole algebraically thing. So now Flip, you can go over to 156 underneath 149 to put the rest of this. All right, well, if we've got the perimeter is 48. Okay, the perimeter is 48. So now I need to figure out, okay, how do I write these expressions? Well, if the perimeter is 48 and two of the sides are x, we need to figure out what are the other two sides. Come on, pen. So let's go ahead and let's take 48, take out the two sides that we know. Well, we've got two x's, so let's take out two x's. That would get us whatever's remaining for the width. But there's two widths. So whatever we get when we have the 48 and we take out the two lengths, we would then divide that by 2. Like imagine if you had 48 and you knew that the length of the side was like 5, you'd say, okay, 48 minus 10 would be 38, but that's the length of the two other sides, so I divide it by 2 to figure out what is that question mark. That's what's going on here, but with an x in place of the 5, because we don't know what it actually is. We'll figure that out later. Okay, so this represents the width. Let's clean this up. 48 divided by 2, that's 24. 2x divided by 2, that's a minus x. So now the two widths are 24 minus x, oops, and 24 minus x. Okay, all of that just to help us figure out what's the area. The area, we know, is 108. The length, we know, is x. The width, we know, is 24 minus x. Remember, area, length times width. How do I solve this? All right, I got to get rid of the parentheses, so I'm going to distribute. 108 equals 24x minus x squared. Okay, that's good. Now I need to know, how could I solve this? Can I go over to the calculator and do the zeros? No. The word algebraically is in there. I have to use solving an equation. Okay, so that means I've got to get everything to one side, and then I've got to factor it. All right, let's get everything to one side. Let's move everything over to the left so that that minus x squared becomes a positive. I'll write it in standard form, which means the x squared goes first. So a positive x squared, when the 24 comes over, it will become a negative 24x plus 108 equals 0. All right, I gotta factor this thing. How am I gonna factor this thing? I gotta split it into two binomials because it's a trinomial. Wait, if I have to split it into two binomials, can't we take the answers from the calculator and help us figure out what the binomials are? Yes, we're going to do that. So I'm going to go over to my calculator, add a new graph. Into my graph, I'm going to type in my trinomial, x squared minus 24x minus 108. Double check it. Looks good. Okay. Oh, no, that was a plus 108. Yes, it was. Okay. Why did I do minus 108? Edit that. You'd have it right next to you, so it'd be easier. What just happened? Everything disappeared. Oops. It's the smartboard, not the calculator. X squared minus 24x plus 108. There we go. It goes off the screen. That's okay. We can adjust the screen. We can zoom it out. Menu, analyze. Nope. Window zoom. We want to zoom out. Ah, there it is right there. We want to know, hey, calculator, what are the answers? What are the zeros? One of them 6. Do it again. Analyze the graph, figure out the other 0. Ah, one of them's 18. So if 6 and 18 are my answers, keep the signs the same. Don't go flipping the signs. Flipping the signs happen when we write our binomials. X minus 6, X minus 18. The only thing left to write, X minus 6 equals 0, X minus 18 equals 0. When we solve those little one-step equations, that's where the signs would change to a positive 18 and a positive 6. So our width and our length must be 18 and 6. Question 1. Oh, by the way, the last couple were all 4-pointers. So 155 and 156 is a 4-point question. 157 is also going to be a 4-point question. 157, you can do this right below it. A school is building a rectangular soccer field. All right, I'm going to draw a rectangle. With an area of 6,000, my inside is 6,000. The soccer field must be 40 yards longer than its width. All right, whatever my width is, I could say X, 40 yards longer, 40 yards bigger, X plus 40 is my length. Determine algebraically. Algebraically again, we've got to show the solving the equation. The dimensions of the soccer field in yards. All right, so my area is 6,000. Area comes from length times width. My length is X times my width is X plus 40. But again, I'm multiplying times a binomial, so I've got to put parentheses around it, equals my area of 6,000. Distribute to get rid of the parentheses. X squared plus 40x equals 6,000. In order to factor this, or in order to solve it, I would have to have one side equal to 0. So I'm going to bump the 6,000 over to the left to join all of the other terms. When I do that, it changes to a minus 6,000 equals 0. Now, yes, you can go over to the calculator and say, hey, calculator, what are my zeros, so that I can figure out how to get my factoring. The calculator, I won't do it, but the calculator will tell you that your zeros are X equals negative 100 and X equals 60. So knowing that, we can work up to figure out, hey, what's our factored form? If my 0 is a negative 100, my binomial was an X, whoops, I'm writing it wrong, was an X plus 100 equals 0. If the X equals 60, my binomial had a minus 60 in it. And then I can put those back together for my factored trinomial. X plus 100, X minus 60. The very last thing to worry about in word problems is, does my answer make sense? Well, what is X in this problem? X is part of the dimensions of a soccer field. So, okay, I've got two dimensions of a soccer field, a negative 100 and a 60. How can a soccer field be negative 100 yards wide? It doesn't make sense. So we're going to cross off this negative 100 as an answer. It just doesn't make sense in the problem. And we're going to go only with the answer of X equals 60. Have we answered what the problem wanted us to answer? Did it want to know what is the width? Well, it says the soccer field's width, blah, blah, blah. Determine algebraically the dimensions of the soccer field in yards. If we figured out X, we've only figured out the width. So we can say that the width is 60 yards, because it wanted to know yards. The length, well, the length came from x plus 40. So 60 plus 40 is 100 yards. Now we have answered the question. 158. 158 you can do right down here below 160, in this space below 160. Oh, and 159 we're going to do as well. That's going to go below 166. I'll remind you of that when we get there. So 158, down below 160, it says, the new Clarendon Park is undergoing renovations to its gardens. One garden that was originally a square is being adjusted so that one side is double its length, while the other side is decreased by 3 meters. The new rectangular garden has an area that's 25% more than its original square garden. Write an equation that can be used to determine the length of the side of the original square garden. Explain how your equation models the situation. Determine the area in square meters of the new rectangular garden. This is a 6-point question. You will see it broken down into your tasks. Again, for space in this booklet, they have smushed it all together. So I'm going to break it down, and we're going to answer each question as it's asked in the problem. So it says, the new Clarendon Park is undergoing renovations. One garden was originally a square. All right, I've got a square. It's being adjusted so that one side is double its length. So whatever this square is, you know what? I'm going to draw an actual square. Let me find my square up here. There's a square. The length of the new side is double the original. So let's see if I can do a matching one and then put it right next to it. There we go. They've taken the original square garden and they've doubled its size. So they put it like a whole new garden right next to it. It's double its length. So if the original length of the garden was x, the length of the entire shape, it has another x next to it. What would we do with each of the lengths? We'd add them together to make a total length of 2x. Well, with that being said, well, if the original was a square, the other sides are really all x's. Okay, so now I know the length of one side is x, the length of the other side is 2x, but they've changed it up again. They have said they're going to decrease. Where does it say it? One side is doubled in length, while the other side is decreased by 3 meters. So they're actually going to cut part of this garden out and maybe reseed it. So they're going to take 3 meters away from the other side of the garden, and they're going to remove all of this section. If they're removing 3 meters, they're taking their original x and they're decreasing the length by 3. So x subtract 3. All right, so now I've got my diagram going. It says the new garden has an area that is 25% more than the original square. Well, what was the area of the original square? The area of a square, you could do length times width, but it's also side squared since each of the sides are the same. So the area is x squared for our original square, the original square that I put the first time. If they're increasing the size of the new garden, the new shape, here I'll put it in blue, this is the new garden right here, it's 25% more. So whatever the original shape was, it's 25% more than that. That would be represented by 0.25, 25% is a decimal, times x squared. And if we add that to the original area of x squared, we'll get the area of the new shape. Well, what's 1x squared plus 0.25x squared? My new area is 1.25x squared. Okay, well, this has gotten me some, like, different information that I now have to use. So let's see, write an equation that can be used to determine the length of a side of the original square garden. The original square garden, that was x. So I have to solve for x. Okay, area is length times width. So that means that this new area of 1.25x squared is my new length times my new width. So my new length is x minus 3. My new width is 2x. And you know what? Since it's multiplying, I set them backwards. My length is actually 2x. It doesn't matter, because multiplying is commutative. So now we've got this as our equation. Oof. That's okay. It's not going to be too bad to solve. We've got 2x times x and 2x times 3. All right, so x times 2x is 2x squared. Negative 3 times 2x is negative 6x equals 1.25x squared. I still need to solve this for x, and I notice that there's 2x squareds there. So I'm going to combine like terms. Since they're on different sides, I do need to bring one over to the other side by doing an opposite. When I do that, I get a 0.75x squared minus 6x equals 0. Did it say I had to do this algebraically? No, it didn't. So you can go to your calculator, graph it, and get these two answers. My zeros are that x equals 0 and x equals 8. Okay, context of the problem. What does x represent? X was the length of the original side. Should a garden be 0, what is this, meters long? No, it doesn't make sense to have a garden that's 0 meters. We're going to cross off that answer. That's not the answer. The answer is that the length of the side is 8 meters long. Well, that's great, but it still wants to know, determine the area in square meters of the new rectangular garden. So this would have been that last part. It would have said, hey, use your answer that you just got to figure out the area of the new garden. Well, the new garden has a length of x minus 3 and a width of 2x. 8 minus 3 is 5. 2 times 8 is 16. 5 times 16 is 80 square meters. 80 meters squared. This was a difficult question, and it's supposed to be because it's a 6-pointer. But different pieces of it you could get partial credit on. I did miss part of the explain. If you caught that, I will go back and do that. When I reread the problem, I was like, oh, I missed the explain. It would have been easier to see if they had broken it down into your tasks, like you will see on the Regents. So explain how your equation models the situation. I'll do that right up here. Twice the, what is this, length or width? Length width decreased by 3. That's enough of a explain. 159, we're going to do over underneath 166. 166 wouldn't need much room, so do 159 underneath 166. It says, a rectangular picture measures 6 inches by 8 inches. Simon wants to build a wooden frame for a picture so that the framed picture takes up a maximum area of 100 inches on his wall. The pieces of wood that he uses to build the frame all have the same width. I'm going to draw a visual for what we're looking at so far. A rectangular picture. I'm going to go back over to my nice rectangles. I'm going to draw a nice rectangle right there. So that's the rectangular picture. Its dimensions are 6 by 8. He wants to put a wooden frame around it. So let me draw a wooden frame that goes around the outside. Trying to make it look like all of the dimensions are the same. Pretty close. Pretty close. So it says that the wooden frame. Simon wants to build a wooden frame for the picture, so the framed picture takes up a maximum area of 100 inches on his wall. Here we go. This is what I was looking for. The pieces of wood that he uses to build the frame all have the same width. So this width and this width should be the same. Okay, write an equation or inequality that could be used to determine the maximum width of the pieces of wood for your frame Simon could create. All right, so we need to figure out what equation would be used to model this. Well, the entire shape has an area of 100 square inches. So the entire shape length times width, well, the length is 6 plus 2 more pieces. Let's call this width x and x for the frame. So the entire width is 6 plus 2x, just like that walkway problem. The other side is 8 plus 2 more pieces of frame. So 8 plus 2 pieces of frame gives us a total area of 100. Okay, well, we would box method this out. When you do the box method, you will get 4x squared plus 28x plus 48 equals 100. It wants us to figure out how big the frame should be. Okay, well, let's solve this. What would x be? And does it say algebraically? Do you see the word algebraically anywhere in the problem? No. Great. So let's do it from the calculator. Let's move the 100 over so that it becomes a minus 100 on the other side. So it would turn into a 4x squared plus 28x minus 13 when we combine 48 minus 100. All right, I just had to pause the video. I was like, where is the 13 coming from? 48 minus 100 definitely isn't 13. I don't know why I wrote a 13 on mine when I worked this out. It's supposed to be a minus 52 equals 0. I don't know why I did that. So with a minus 52 in there, we can go ahead and find the zeros from the calculator, which yes, we are going to. So I want to show you what happens. So in a graph page, I'll type in my, let's see, 4x squared. My 4 didn't go in. Plus 28x. And then my minus 52. I get this picture. Boy, those zeros don't look very good, do they? They don't look like they hit at nice spots on the x-axis. Oops, wrong one. Wrong one. I hit minimum. Analyze graph 0. Ah, I get a decimal. Yeah, that's okay. Oh, I hit minimum again. All right, so I get a negative 8.52 and a positive 1.52. So I do have to check the original problem because maybe that's not how it wanted the answers. If it says to the nearest tenth of an inch, that answer is not good enough. That's not to the nearest tenth of an inch. Plus, have I figured out, does the answer make sense? Well, if X was the width of the frame, negative 8 point something doesn't even make sense because you can't have a negative width of a frame. So now we'll adjust this 1.52, rounded to the nearest tenth, 1.5. And if you think about it, 1.5 inches for a picture frame, that sounds pretty good for the outside of the picture frame. It sounds logical. So there we go. We just have to explain how your equation or inequality models the situation. Again, we would do, move it back up again. You could draw the picture. You could say total length is 6 plus 2 widths. And then on the side, total width. Oh, I didn't mean width over here. Plus 2 frames. Total width is 8 plus 2 frames. Something that leads whoever's grading this to know where you got your binomials from. And the last question, I threw this one in right at the end because it seemed so easy. In the function, the minimum value. Hey, that button I kept accidentally hidden, that said minimum. So this is just going to be a calculator question. Let's do this super fast. So in the calculator, I put the parentheses in the way they look. X minus 2 parenthesis squared plus 4, hit enter. Oh, it doesn't even cross the x-axis, but I could figure out the minimum. Analyze graph minimum. It's that lowest point. The minimum happens at 2, 4. Ah, so should I circle 2 or should I circle 4? Well, the question says when x is. So from our point, x is 2. So I would circle 2. And that is it.